Okay, welcome to Chapter 16, Section 3, Reflection and Colors. And our key ideas: how do objects interact with incoming light? How can you see an image in a mirror? Why do we see colors? So, how do objects interact with incoming light? Every object reflects some light and absorbs some light. Light can be modeled as something called a ray. This is different from the wave and particle model of light. This is just showing how light is reflected or refracted. A light ray is a line in space that matches the direction of flow of radiant energy. The direction of the light rays in the same direction of the wave travel or as the path of the photons. Light rays are used to describe reflection and refraction. And we have something called geometrical optics. That's the study of light in cases in which light behaves like a ray. And we use something called ray diagrams, which are drawings that use light rays to trace the path of light. So here you can see somewhat of a drawing of the light rays. You can see as the black lines here, and then it reflecting off of the surface. Rough surfaces reflect light rays in different directions, and that's called diffuse reflection. So light bounces off in random directions. Then you have smooth surfaces reflect light rays in one direction, and that's called specular. The law of reflection is the angle of incidence equals the angle of reflection, and the angle of reflection is the angle of the light rays reflecting off of a surface, and the angle of incidence is the angle of the light rays striking the surface. So to make a little more sense here, you have when a light ray hits a smooth surface, the angle of incidence equals the angle of reflection. So the incoming light, this is the angle of incidence. The incident ray comes down toward the mirror. That's the angle of incidence measured against the normal, and the normal is a line, kind of a make-believe line that we have that's perpendicular to the surface that the light is in contact with. And then you have the angle of reflection, where the light has been reflected off of the mirror in this particular case. This is the angle of reflection. And these two angles on a flat mirror will be exactly the same angles. So, visual concept on the law of reflection.
When an object strikes a perfectly smooth surface, it will bound off the surface at exactly the angle it struck the surface. When a billiard ball strikes the bumpers of a billiards table, it bounces off at exactly the angle it struck the table. Let's look at this more closely. First, we'll draw a line perpendicular to the wall of the billiards table. Now, look at the angles of the ball's path. As you can see, the ball left the wall of the billiards table at the same angle it came in at. This is true with light and sound waves just as it is with billiard balls. The angle of the incident ray equals the angle of the reflected ray.
So mirrors. How can you see an image in a mirror? Mirrors reflect light as described by the law of reflection, and this light reaches your eyes. The type of image you perceive depends on the type of the mirror. And you see here that flat mirrors form vertical images by reflection, or virtual images by reflection. And a virtual image is an image from which light rays appear to diverge even though they are not actually focused there. A virtual image cannot be projected on a screen. And here the thing about it is say light that leaves from your knee travels up, bounces off the mirror, and it bounces at the same angle that it came in at, and will reach your eyes. The thing about it is your eye interprets that ray not to come actually from your knee, but from behind the mirror, where it looks like right here where your knee was. So that is the way you're able to see. One from the top of your head goes back to your eyes, but it looks like it came from back behind the mirror somewhere. So your eye interprets an image behind the mirror instead of seeing something different in front of it. Alright, so comparing real images and virtual images. Virtual images are always formed behind the mirror, And real images are always formed in front of a mirror where you can put a piece of paper and see it, or on the other side of a lens in this particular case.
When you go to the movies or when your teacher uses an overhead projector, the image that is being projected onto the screen is called a real image. Real images are formed due to the special properties of the lens or mirror used to create them. In the situation shown here, a converging lens bends many different light rays from a point on the tip of the pencil so that they come together at a point in another location. If you place a reflecting surface at that location, you will see an image of the tip of the pencil. A real image forms when many rays of light from an object come together at a specific location. Real images are often upside down when compared to the object. Another kind of image is called a virtual image. You are seeing a virtual image anytime you look in the mirror. Unlike real images, virtual images cannot be projected onto a screen. The law of reflection allows you to predict how light rays will travel when they reflect from a mirror. Light rays from here will change direction when they strike the mirror. Because your brain expects light to travel in a straight line from the object to your eye, the light appears to the viewer as if it came from here. Similarly, light coming from this point seems like it's coming from here. A virtual image is an image that appears to be at a location from which light does not actually come. These light rays seem to the man as if they came from behind the mirror, but they actually came from in front of it.
Okay, so curved mirrors can distort images. Because the surface is not flat, the line perpendicular to the normal points in different directions for different parts of the mirror. So you have something called convex mirrors that bulge out and concave mirrors that curve inward, basically. So concave mirrors can create real images, and they are used to focus reflected light. A virtual image may form behind a concave mirror, and a real image may form in front of a concave mirror. A real image is any image that's formed by the intersecting of light rays and can be projected on some kind of screen. You can put a piece of paper or screen there and an image will be formed on it. Light rays exist at the point where the real image appears. So let's look at comparing concave, convex, and plane mirrors.
Comparing concave, convex, and plane mirrors. A concave mirror is a mirror that is curved inward like the inside of a spoon. A convex mirror is a mirror that is curved outward like the back of a spoon. A plane mirror is a mirror whose surface lies in a plane.
Okay, so the three types of mirrors here. On a convex mirror, where it's bulging out and you have a object in front of it, produces a virtual image behind where the image looks like it's behind the mirror. In a convex mirror, this will always be the case. It'll always produce a virtual image no matter where the object is at. On a concave mirror, you have something called a focal point here. If the object is behind the focal point and upright here, you will get an image formed that it'll be upside down here, but you can get an image formed that you can put a piece of paper or a screen right there and see that image. If you move the image in front of the focal point, the image then becomes virtual image. It's formed behind the mirror and it actually looks larger. This is the basis for a lot of your makeup mirrors that are curved to where you get fairly close to them and it makes everything in the mirror look very large so you can see it, but that's the basis for those types of mirrors. So why do we see colors? The colors that you perceive depend on the wavelengths of the visible light that reach your eyes. Objects have the color of the wavelengths they reflect. So white light from the sun actually contains light from the visible wavelengths of the electromagnetic spectrum. It's actually a combination of all the visible colors. Mixtures of colors produce other colors. So colors may add or subtract to produce other colors. Additive primary colors are red, green, and blue. Mixing light of the three additive primary colors makes white light. So add red, green, and blue together, you get white light. Subtractive primary colors, yellow, cyan, and magenta. Cyan being kind of a light bluish and magenta being somewhat of a reddish color. If filters or pigments of all three colors are combined in equal proportion, all visible light is absorbed. And black is the absence of color, or all color is absorbed. So let's look at additive color mixing here.
Primary colors of light can mix to form other colors. Blue, red, and green can be added together to give other colors. When you shine two or more colored lamps onto a screen, the light mixes by addition. The light mixes additively because each spot of the screen is reflecting all the colors of light that fall on it at that point. When all three primary colors are combined, all the colors are reflected back from the screen and the result is white light. Different amounts of the primary colors can form almost all of the colors we see. Red and yellow, for example, appear orange when they combine. However, red and green combine to appear yellow. So, 2 parts red light and 1 part green light will appear orange when combined. Using different amounts of the 3 primary colors, almost any color can be displayed.
Alright, so let's watch on subtractive colors.
Finger paints, food coloring, and similar substances are called pigments. When you mix colored pigments, they follow a set of rules, known as color subtraction. Pigments combine subtractively because each pigment absorbs all wavelengths of light except for the wavelength that gives the pigment its color. When all 3 primary subtractive colors are combined, all wavelengths are absorbed, and the result is black. Let's start with a black outline. This will help make a sharp image when we add pigments. Magenta is one of the 3 primary pigments. Cyan is another, and yellow is the third. By printing the 3 primary pigments plus black, any color can be obtained. This is called 4-color printing. Comic books, textbooks, and cereal boxes